Welcome back. This is going to be Unit 2, starting video number 1, History and Models of the Atoms. Okay, so I gave you a foldable or a handout on Friday. This is what you need to either cut out the pictures and put them in your journal and write information about the person, or you can use the boxes. The one that we're not going to use is Marie Curie. So instead of her, we are going to use Schrodinger. So when I get to that, I'll let you know. So you can either cross out her name or you can just write it in your journal. So let's get started. The first guy that even came up with the atom was Democritus. Okay, so this guy, we just have a sculpture of him, and he believes the universe was made of invisible units called atoms. He's the one that came up with the name atoms. It was in 14 BC. Everybody thought he was a quack, so it took 2,000 years for anybody to prove him wrong. I mean, to prove him right, sorry. They all thought he was crazy, and now we know he was very intelligent. Okay, the next guy we're going to talk about is the father of chemistry, John Dalton. He's the one that took the word atoms from Democritus and decided to, hey, I'm going to test this thing. Okay, so he wrote the first atomic theory, and he had 4 postulates. Okay, we call them postulates because they're what he said was happening. Okay, let me see if I can get my thing working here. Options. Okay, so number 1. Come on, why are you not highlighting? All right, we're going to go back. I'm going to pause the video for a second because I want to make sure I get this thing working. Okay, so we're back. Okay, so there it is. All elements are composed of tiny individual particles called atoms. That was his first statement. Okay, number 2 was atoms of the same element. Atoms of the same element are identical. Atoms of any one element are different from those of any one element are different from those of any other element. Okay. Number 3, atoms of different elements combine in simple whole numbers and ratios to form compounds. We know that this is true. You're going to find that he was correct in most of it, but not all of it. Okay. In a chemical reactions, atoms are combined, separated, or rearranged. Make sure that you have all 4 of these postulates in your journal. Okay. So Dalton was wrong about elements of the same type being identical. So his postulate number being number 2 was incorrect. So he was wrong because we found out that there are some elements that have different number of neutrons. So make sure that you write this down and you write this word isotopes because we're going to be working with those in class. Okay, isotopes, they have a different number of neutrons. I put it right there too. Okay, so Frederick Soddy, if you want to write this down, I'm not going to test you on it, but he was the one that proposed the idea of isotopes. So John Dalton was way back when, and then isotopes are the atoms of the same element having different masses. So isotopes, and I would write this down though because we're going to talk about this again, and so this will be the 3rd or 4th time you'll see this by the end of this unit. Okay, Soddy won the Nobel Prize. We're not going to worry about that. But he did come up with the isotope. He's the one that studied it and found them. Okay, but Dalton, going back to Dalton, and in 1804, if you go back from 1804 to 1912, about 100 years later, we found isotopes. Okay, he proposed this model. So I want you to draw this model here. Let's see. No, sorry, it's not there. He proposed the billiard model. Basically, it looks like this. Looks like a billiard ball or a pool cue. Okay, so that's his model. This theory proposed that the matter was composed of small spherical particles, but evidence we're going to find out later is not true. So draw that model right here. Draw the little circle with shaded in. It's a sphere. Okay, and that was John Dalton. Okay, moving on. Okay, so next you would have Marie Curie, but we're not going to do anything about Marie Curie. Okay, during the 1900s, evidence was discovered regarding charges. Okay, so think about why we were having new evidence found. It was Industrial Revolution time in the 1900s, and so we were getting more technologies, so more things were being found at this time. All right, atoms have a positive charge and positive and negative charges, right? So we're going to find out why here in just a minute. Remember, Dalton's was just a circle, so we're going to move on from there because each of these people after him are going to, because of the technology, going to find new parts of the atomic model. The next one we're going to talk about is J.J. Thompson. J.J. Thompson had the plum pudding. Make sure you write that down because that usually shows up on a test right here. Or it's like a chocolate chip cookie model because it looks like a chocolate chip cookie. Okay. Using the available data, J.J. Thompson came up with the idea of having particles inside the billiard ball. So he still said it was a sphere, but now we have charges like positives and negatives. He also used a cathode ray experiment to discover this model. So there's his model right here, plum pudding. See, it kind of looks like a chocolate chip cookie. Everything's all in there. So it's a cathode ray experiment is what he used. Okay, so make sure you have that word in there. And he said it was positive and negatives. If you notice, he has the same amount of positives and negatives because it's a neutral atom. Okay. All right, so J.J. Thompson is known for discovering the electron. And this, my friends, is his model. He put the cathode ray tube in here, and all of these negative charges started going towards a positive plate. Okay, so that told him that because positives and negatives attract each other, that they are since there's a positive plate and a negative charges, so he found the negative charges, which are the electrons. Okay. Cathode rays have identical properties regarding the use of the elements produced in them. Elements must contain identical charges. Okay, so atoms are neutral. We know that. We knew that. And so they must have positive particles in them. Okay, that brings us to our next person, which is Robert Milken. Okay, Robert Milken. Robert Milken determines the mass of the electron. So he finds out that the mass of the electron is very, very, very small. Okay, it's small. So small that we don't even usually count the electron. Okay, it's negligible. Okay. So the mass of the electron is teeny, teeny, tiny. Okay, so he just found the mass of the electron. Now we're getting to Ernest Rutherford. Rutherford discovered the huge flaw in the previous conceptions of the atom. Basically, he didn't think it was the plum pudding model. He discovered the nucleus. Okay, so he discovered the nucleus and the positive protons. Okay, he did this with a gold foil experiment. Okay, but he did not know about the neutrons. Okay, but he also said that it's mostly empty space. His atoms are mostly empty space. So make sure you get that information down. Here is his gold foil experiment. He basically shot particles into some gold foil. He thought they were going to just go straight through, but when it bounced back, he said there was something in there that was deflecting him. Okay, and alpha particles are positive protons. So if they would all went through, then there wouldn't have been a positive charge in there. But remember, like charges will repel each other. All right. So here's what we had before. Okay. And here's what he did, what he noticed. When he shot particles in there, they started curving. And so he basically came up with, well, let's take a look at this real quick. I forgot about this slide. He basically said, well, why is this happening? Can you determine the shape? Because here's what he thought happened. Here's what was happening. So let's see. Okay. All right. So Rutherford found most of the 99% of the alpha particles, which are the nucleus, because they're positive core. So here's what he came up with. Okay. So here's his model right here. Draw that model. All right. So he said all the positive charges are in the same spot, and it's a lot of empty space, but all the negative charges are around it. So most of the particles went through, very few were deflected, so that means that there was very, very tiny nucleus. The nucleus is small, the nucleus is dense, and it's positively charged. So make sure you write this. This is his conclusions. Okay? All right, now's Bohr. This is one you're probably most familiar with because I like to call his the Jimmy Neutron model because you guys know some of you guys know Jimmy Neutron. But he discovered that electrons exist in several distinct layers or levels. And this is the electron, sorry. They travel around the nucleus like planets, okay? So we have electron orbits. And electrons can jump between levels with energy being added and released. That's what he discovered, okay? So here is his model. Okay, so draw this in your notes. Okay. Whoa, what happened to my? Okay, my pen's doing something funny. Okay, draw this model right here. Okay, this is called the Bohr model or the solar system model. Okay, and he said there were levels, so it's kind of like a staircase. Okay, Heisenberg and Schrodinger, instead of Curie, used these. They found electrons to be in fuzzy regions called clouds, and they improved on his model. And they also came up with the quantum mechanic model. We're getting kind of long here, so I'm going to finish up quickly. Basically, this is the current model. The quantum mechanic model is the current one. But I want to add James Chadwick in here. He proposed that there was a third subatomic, know that word there, subatomic particle called the neutron. And it helps stabilize the protons in the nucleus. It worked to help make the atomic bomb. Okay, so just some information here. If you missed that, just go back. Just some information here. Most things that we do can be explained using the Dalton's model or Dalton's postulates or Bohr's model. The quantum mechanical model, although most accurate, is complex even at university level. So we are not going to be working with the quantum model in here. All right, I believe that's it, guys. All right, bring these to class and show me so you can do the labs. All right, have a good night.